Hello and welcome. Today we're going to be talking about tectonic plate boundaries. So to begin, what are plate boundaries? Now, plate boundaries are areas defined by motion between tectonic plates which result in the ever-changing appearance and landscape of the Earth. The movement of these plates is driven by density differences between the types of plates and the convection currents in the mantle. Depending on the relative motion at each plate boundary determines which geological features may form on the surface and whether crusts may be created or destroyed. On this graphic on the right, we have the different plate boundaries and plates which make up the surface of our Earth. So, what are the main types of plate boundaries? Here I have them listed. There are three main types of plate boundaries. They are divergent, convergent, and transform boundaries. On this graphic on the right, we have a transform boundary, a divergent boundary, and a convergent boundary. And down on this area beneath, we have a convergent boundary where we have oceanic crust overriding a piece of subducting oceanic crust, creating an island arc such as the Hawaiian Islands. Here we have a piece of lithosphere moving over a hot spot, creating a shield volcano. Here we have two pieces of oceanic crust diverging, creating a ocean ridge. And here we have a convergent boundary where oceanic crust, which is denser than this overriding continental crust, is subducting underneath. It's then being heated. That magma moves upwards and creates a arc of volcanoes. So to get in a little bit more detail, our first type of boundary that we're going to cover are divergent plate boundaries. Now, divergent boundaries are categorized by tensional forces between two tectonic plates, which occur as rising magma from the asthenosphere. That's this area underneath the lithosphere, which we know as the crust. As the convection currents in the asthenosphere start to push apart the plates, new crust rises. This results in the thinning of the crust. We can see in the motion here, this plate is moving to the left, this plate is moving to the right, creating a gap in between, and something has to be in that gap, so the asthenosphere rises and magma rises and creates a ridge in the middle. So it's important to note that these boundaries result in the creation of new crust. And down here we have the force diagrams with one arrow pushing to the left, pushing to the right, and we describe these as tensional forces. An example of a divergent plate boundary in real life is the Mid-Atlantic Ridge, where we have the North American plate moving to the left and the Eurasian plate moving to the right, and the Mid-Atlantic Ridge filling in the middle and the gap created between these two plates moving apart from each other. And this provides evidence that these plates are still moving today. Next, we have convergent plate boundaries, which are categorized by compressional forces, which occur as a result of the asthenosphere pushing two plates together. And as they push together, one of them has to go down or subduct, and one has to override. In this case, the oceanic crust is more dense, so it sinks down. Now, the lithosphere of this continental crust is less dense, so it overrides. This results in the destruction of old crust. We have the oceanic crust here subducting and becoming destroyed. And we have the new crust forming as this one melts, and it forms the surface in the shape of a volcanic arc. And here we have the forces down here. We have this arrow pushing to the right and this arrow pushing to the left, and we know that force as compressional. A example of a convergent plate boundary in life is the Aleutian Islands, which formed as the North American plate pushed against the Pacific plate being a more dense oceanic crust, subducted, and this North American plate overrided, creating a chain of islands, which we know as the Aleutian Islands. Finally, we have transform plate boundaries, which are categorized by shearing forces, which are caused by convection currents causing pieces of tectonic plate to move past one another. And it is important to note that these boundaries do not create or destroy any crust. Think about it, if you were to take your hands and move them back and forth against each other until you develop some friction, you notice that your hand's not moving into one another, it's not moving away, your hands are moving side by side, creating friction. And that's what we have. We call that a shearing force. We see one is moving down, one is moving up, and the forces are parallel to each other. So an example of a transform plate boundary, we have the San Andreas Fault in California. It's probably the most famous and active transform plate boundary in the world, and is the result of the parallel movement of the North American plate here, and the South American plate and the Pacific plate moving here. You can see the North American plate is moving towards the southeast, the Pacific plate is moving towards the northwest, and these parallel and opposing forces create what we know as a transform plate boundary. And this fault, the San Andreas Fault, is also the primary cause of the earthquakes which are common to Western California. So by the end of this video, you will be able to name the 3 types of plate boundaries and 3 real-life examples of the plate boundaries. I would like for you to now answer the question which I have posted along with the video, and I look forward to seeing you in class. Thank you.